Good morning, all. Today, let's see different file types in system calls for file subsystem in Unix. Unix systems, most files are either regular files or directories. There are some additional types of files as well. The regular files, it is the most common file type containing some form of data. All binary executable files conform to a format allowing the kernel to identify where to load a program's text and data. Directory file. Directory file is a file containing other files' names and pointers to information on this file. Any process having read permissions for a directory file can read the directory content. Only the kernel can write to a directory file directly. Then are some block special files. A file type providing buffered input-output access is fixed size units to devices like disk drive. Character special file, a file type providing unbuffered input-output access in variable size units to devices. FIFO, first in, first out, a file type used for communication between processes. Sometimes it is called as a named pipe. Then socket, a file type used for network communication between processes as well as for non-network communication between processes on a single host. Symbolic link, a file type pointing to another file is symbolic link. On the system, all devices are block special files or character special files. The type of file is encoded in the ST mode member of stat structure. The file type can be determined with macros. The arguments to macros is the stat mode member to the stat structure. So the macro name S underscore IFREG means it is a regular file. For directory file, it is dir. Character special file, CHR. Block special file is BLK. For FIFO or pipe, it is FIFO. Symbolic link is link. And for socket, it is SOC. These are the micro names for file type. Let's set user ID and set user group ID. So each process having 6 or more IDs associated with it, the real user ID, the real group ID, who we really are identified. Above two fields are taken from entry in the password file when logging. During a login session, these files don't change normally for super users. Processes, there are ways to change them. The effective user ID, effective group ID, and supplementary group ID used for file access permission check. The saved user ID and saved set group ID saved for execution function. They contain the effective user ID's copies and effective group ID's copies when executed a program. Each file having an owner and group owner. The stat structure's STUID member specifies an owner. The stat structure's STGID specifies group owner. When a program file executes, a processor's effective user ID is usually a real user ID as well as effective group ID is usually the real group ID. So the special flag in file mode words can be set which says when this file is executed, then set the process effective user ID to be the file owner and set process effective group ID to be the file's group owner. So above two bits in the files mode, words are known as set user ID and set group ID, which sets GID and set UID bits. Then file access permission. For a file, set mode value enforce access permission bits by various functions. Three categories, read, write, and execute, are used in many ways. Whenever want to open any file type by name must have execute permission in which each directory in the name, including the current directory, is implied. Hence, a directory execute permission bit is called the search bit. For a directory, read permission and execute permission mean different things. Read permission lets us read the directory, obtaining all the file names listed in the directory. Execute permission lets us pass through the directory when it is a path name component which is trying to access. The new file cannot be created in a directory unless having write and execute permission in the directory.